Okay, question 2 is giving us a triangle with 3 vertices, so A, B and C as coordinates. We could write down the position vectors O to A, which will be 1, 1, 3, O to B, which is 5, 9, minus 5, and O to C, which is 6, 5, minus 4. And it says there's this point somewhere on A to B, the line A to B, such that A to P and P to B are 3 to 1. So if you imagine the line here, where we've got A there and B there, then P is going to be like here. Oops, P here. And we've got this other point C, and it says that show that C to P, so here, put C there, show that that's perpendicular. So how are we going to do that? We need the vectors A to P and C to P. So A to P is going to be 3/4 of A to B. So can we get A to B? Yes, we can. A to B is going to be, if you imagine O being down here, A to B is going to be A to O plus O to B. So in other words, negative A plus B. Negative of this plus this. So let's work that out. So we're going to have 4, 8, minus 8. And A to P is 3/4 of that, because the ratio is 3 to 1. So that's going to be 3, 6, minus 6. So we've got the vector A to P. It would be useful to have the position vector for P. So this vector here would be useful to have. So let's write that down as well. So how are we going to work out O to P? Well, that's going to be, we're going to go back down here. No, we're not. O to P is going to be O to A plus A to P. So O to P is going to be equal to O to A plus A to P. So that's going to be our 113, yeah, plus this 3, 6, minus 6, which gives us 4, 7, minus 3. So that's P's coordinate, if you like. P's coordinate we can write down is 4, 7, minus 3. That's going to allow us to get C to P, or P to C. C to P, if I draw another line, we want C to P, we're going to want to go from C to O plus O to P. So that's going to be -6 minus 5, 4. Plus, so that's back down the green one, and then plus P's position vector O to P, which is 4, 7, minus 3. And that gives us -2, 2, 1. So we're ready to go now. We've got C to P, and we've got A to B. And we didn't actually need A to P. Oh, that's annoying. Oh, we kind of did. Anyway, so A to B dotted with -2, 2, 1 should give us 0, because if the dot product of anything is equal to 0, so if we had A dot B and we found out the dot product and we got 0, that shows that it's perpendicular. So that's what we're going to do with our two vectors. We're going to do -2, 2, 1 dotted with 4, 8, -8. And we're hopefully going to get 0. So that's going to be -2 times times +4 plus 2 times 8 plus 1 times -8. And we're going to get -8 plus 16 -8, which is 0. Therefore, it is perpendicular.